All right, welcome back. So let's go ahead and talk about lesson 2, volume of rectangular prisms. Before we do that, let's build on area. How they measure that is how many squares can fit in this shape. So if I drew something like this, how many squares? Well, 1, 2, 3. Well, let's count. 1, 2, 3, 4, 5, 6. That would be 6 squares. 1, 2, 3, 4, 5, 6. 6 by 6. So that the area would equal 36 square units. Okay, so that's area. But when we're talking about volume, we're talking about something three-dimensional. So it would be talking about like if you had a three-dimensional shape. And it helps to understand art a little bit, understand depth. Okay? So how many little cubes could fit in a shape like this? And what do I mean by that? All right, so I have this little box, and it has these little cubic units. So if you had a shape like this, you can see this right here has a bunch of little cubes. How many of these little cubes could fit in this big shape right here? But then you have something like this, and this would represent area. It's kind of like what this shape is that I drew right there. Okay, so this would represent area. How many of these little cubes would it take to make basically a flat shape such as this orange object? All right, so then let's find area of this. Well, there's 10, the length would be 10, the width would be 10, so length times width, 10 times 10 would be 100. Now, volume is, the word that I like to describe volume is space. How much space? So if I'm in a room right now, the area would be how many squares of carpet can I fit on the floor? The volume of this room would be how much space I have to move around. Okay? So how much space is inside of this shape right here, this cube? Okay? Well, the way you would figure that out is you find the area of the bottom level. Okay? So the bottom level is 10 by 10. The area of the bottom level would be the same for this shape as this shape right here. So that would be 100 cubic units. Okay? So that's the bottom. Okay, now, how many levels are there? So there's 100 units on the bottom. Then the next level, the second level up, there'd be 100 units, 100 units, 100 units, 100 units, 100. Well, how many levels is this building? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 levels. So this would be 100 rooms on the bottom level, and then there's 10 levels of 100 rooms, so that would be 100 times 10. So this has 1,000 little units this size inside of that. All right, so let's take this rectangular prism right here, and we're going to find out how much space is inside of it. Okay, so across the bottom there's a formula to find the volume, which is how much space of any rectangular prism. So you do length times width, which is the base. The base meaning this right here. Okay, this is the bottom right there. And then let's say the width is 3 inches, and the length, 1, 2, 3, 4, 5, 6, 7, is 8 inches. So you find the base, which is the bottom level of your building. Okay, so 8 times 3, and this would be, they call it volume equals base times the height. So the volume is really base, big B, times height. All right, and big B is length times width. So you can use either one of these formulas. But if you use this second formula, you just have to know that the B stands for, it's the same thing as length times width. So just so you know, I'm going to do length times width. So this would be 8 times 3 You do that first, you're going to get 24 inches squared. And then you take that and you multiply it by whatever the height is. Well, let's say the height is 3 as well. So you take 24 times 3, and so that would be, don't be afraid to do scratch work if you need to. 3 times 4 is 12, carry the 1. 3 times 2 is 6, plus 1 is 7. So the volume will be 72 inches squared. And inches cubed. Okay, whenever you're doing volume, when you do your unit of measurement, it's cubed, which is to the 3rd power. Okay? So let's move on. Let's do another problem. Alright, you guys try this problem by yourself. Pause the YouTube video. Pause. Alright, welcome back. Okay, so now you guys use these numbers to find the volume. Basically, you just multiply length times width times height. So your volume, the length is going to be 4. Width is going to be 3. That's your big base. Okay, that's basically the area of the bottom floor of your building. Then you take that times 10. Your volume is going to be 12 times 10, which is going to be 120 inches cubed. Awesome job. Alright, you guys try one. Go ahead and pause your YouTube video. Pause. Welcome back. Hopefully you got the right answer to this. Let me do it really quick. Now that you guys have a chance to do this, I'm going to do length is 3, width is 2, set that equal to volume, multiply that by height. Well, actually we know volume, so we don't have to put a variable there because we know that volume is equal to 90. Okay? 3 times 2 is going to be 6 times h equals 90. Divide both sides by 6. 6 cancels out, so you're going to have your height is equal to 90 divided by 6. Don't be afraid to do scratch work. So your height is going to be 15 inches. Alright, last thing we're going to talk about is our cubes. Okay, so if I have a cube right there, and it's 1 inch by 1 inch by 1 inch, the volume of that cube, well, if one of the edges is 1 inch and it's a cube, that means all the edges are 1 inch. So it's 1 inch, and then the height is also 1 inch. So the volume would be length times width times height. Well, all those are big fat ones. Okay, so the volume is 1 times 1 times 1, so the volume of this is 1 inch cubed. But imagine if this was a little bit of a bigger cube. Your volume wouldn't be 1 times 1 times 1, it would be 2 times 2 times 2. And this is only true with cubes. We were doing rectangular prisms that had different dimensions. But this, they all have the same length of a dimension, so it's a perfect cube. Okay? So we're going to do 2 times 2 times 2, so your volume is now going to be 8 inches, because 2 times 2 is 4, 4 times 2 is 8, so this will be 8 inches cubed. Notice that when the length increases only by 1 inch for all the edges, we have exponential growth for the volume. Okay, so this would be 3 times 3 times 3, which would be, of course, 27 inches cubed. Okay, this right here would be 4 times 4 times 4, which would be 64 inches cubed. And this would be 5 times 5 times 5, which would be 125 inches cubed. As you can see, it is an exponential, there's an exponential growth every time you increase just 1 inch on your dimensions. So when you get up to 10 times 10 times 10, how many little cubes are in this? How much area is in here? How much space? Well, there's 1,000 little tiny cubes when you go 10 times 10 times 10. All right, that concludes today's lesson. Hope you enjoyed it. Talk to you guys later. All right, this one's a little bit different. Say we have your length or your width is 5 and your length is, or your width is 3. So length 5, width 3. But we don't know the height. So say you want to find the height of a building, and you don't know, but they do tell you the volume. So you still use your formula the same way. We're going to have to do some algebra here. Okay, so we're going to do length times width times height. Let's substitute everything in that we have. Okay, so I know the length is 5, the width is 3, and I do not know the height, but I do know the volume, and that is 90. Okay, so let's start doing some algebra. But before we do our algebra, let's do 5 times 3. Let's evaluate that first. 5 times 3 is 15 times h equals 90. Okay, what side do we start on? The side with a variable. What's opposite multiplying 15? Dividing by 15. You divide this side by 15, what do you have to do to this side? Good, divide that side by 15. The 15's cancel out, so we know our height is going to be equal to 90 divided by 15, which is 6. So we know that our height is 6 inches.